Hi, in this video I'm finishing section 1.7 on inequalities. Okay, so I started quadratic inequalities last time. I will do today, I'll do 2 more examples with quadratic inequalities, or 1 example and 1 application, and 1 example with rational inequalities. So we're going to solve. So this is a continuation of section 1.7. We are going to solve the inequality, the quadratic inequality, 2x squared plus 7x plus 3 greater than or equal to 0. Okay, so the first step is to solve the associated or the corresponding quadratic equation. So solve first. The associated quadratic equation. We can solve this equation by factoring. These factors, the expression on the left factors as 2x plus 1 and x plus 3. So the solutions of the quadratic, the associated quadratic equation are -1/2 and -3. Okay, so that's going to give us 3 intervals. On the second step, the numbers, the solutions of the associated quadratic equation. Those were -3 and -1/2. Divide the number line into 3 intervals. So the intervals are -3 to infinity, or -3 to so -infinity to -3. -3 to -1/2. And -1/2 to infinity. So the expression 2x squared plus 7x plus 3 is going to be always positive or always negative on those intervals. And it's going to be 0 at -3 and -1/2. Those are the only 2 values at which this expression becomes 0. Now, we have in the inequality, we have greater than or equal to 0, so they are going to be solutions. And in step number 3, we're going to make a table with the test values. We have the interval, the test interval. We are going to pick a test value in that interval. And determine whether 2x squared plus 7x plus 3 is greater than or equal to 0. Is this true? Okay, the first interval is -infinity to -3. We're going to write down the intervals. So on the first interval, we can pick -4 as a test value. And let's plug it in. 2 times -4 squared plus 7 times -4 plus 3. That is equal to 7. So that's 16 times 2, that's 32. 32 minus 28 is 4. 4 plus 3 is 7. So that is indeed greater than or equal to 0. So this is true. Next one, we're going to, in a -3, -1/2, we're going to pick -1. So this is 2 minus 7 plus 3. 2 minus 7 is -5. -5 plus 3 is -2. So this is negative. So the statement is false. And -1 to infinity, the easiest value I can think of is 0. So that's going to be 0 plus 3, which is 3. And that is indeed greater than or equal than 0. So since the inequality involves the symbol greater than or equal to, or greater than or equal to, -3 and -1/2 and -3 are also solutions. And the solution set is going to be, the expression is positive on -infinity, -3. And -1/2 to infinity is a solution. So we're going to use the union symbol that I mentioned when I was reading the interval notation. So that's -1/2 to infinity. So this symbol means union. We have two disjoint intervals. That is two intervals that don't have any numbers in common. So we write this as a union of two intervals. Okay, so I'm going to do an application of quadratic inequalities. That's example 7 on page 155. So if a projectile is launched from ground level with an initial velocity of 96 feet per second, its height is in feet 10 seconds after launching is given by the following equation. S equals -16t squared plus 96t. When will the projectile be greater than 80 feet above ground level? So greater than, we want to solve S greater than 80. But S is -16t squared plus 96t greater than 80. So this is what I'm going to do. I'm going to bring this to the other side. I'm going to bring the minus 16t squared plus 96t. I'm going to bring this to the other side with opposite sign. So 0 is greater than 16t squared minus 96t plus 80. Or to make it easier to read, I'm going to switch them. I'm going to switch the sides as 16t squared minus 96t plus 80 less than 0. And I can simplify this a little bit. So we learned how to solve inequalities. So I can factor out the negative 16. 16, 96, and 80 are all divisible by 16. So I can factor this out. And 16 is positive. So whenever we divide by 16, the inequality symbol doesn't change, remains the same. So t squared minus 6t plus 5 is negative. Or less than 0. Okay, so we're going to solve this quadratic inequality. So we need to solve first. Solve first. I'm not going to write step 1, step 2, step 3 this time. So let's solve first. T squared minus 6t plus 5 equals 0. The left side factors as t minus 5, t minus 1. So the solutions are 1 and 5. We have 3 test intervals. The intervals that we're going to test or I should say test intervals, are negative infinity, comma 1, 1 to 5, and 5 to infinity. And we're going to make a table to determine the solution interval or intervals. So we have the interval. A test value inside that interval. And whether the expression, I was able to simplify this as t squared minus 60 plus 5 less than 0, true. So let's write down the intervals. This is actually positive. Okay, I'll probably have to close this whiteboard because it froze. So I'm going to close the whiteboard and reopen it. Okay, so let's try again. Okay, so the intervals are negative infinity, comma 1, 1, comma 5, and 5 to infinity. The test values are on negative infinity to 1. The simplest I can think of is 0. So whenever we evaluate, this is 0 minus 0 plus 5, which is positive, so this is false. Then between 1 and 5, let's evaluate 2. So that's 4 minus 12 plus 5. It's negative 3. -3 is negative, so this is true. And 5 to infinity, let's evaluate 6. So 6 squared minus 6 times 6 is 0. That is 5, which is positive, and this is false. That is t squared minus 6t plus 5 less than 0 is false. And the solution set is 1, 5. So the projectile, back to the original question. The projectile will be greater than 80 feet above ground level between 1 second and 5 seconds after it is launched. The projectile will be, will be greater than 5 feet up, than 80 feet above ground level between 1 second and 5 seconds after it is launched. Okay, and the next type of inequality will be, the last type of inequality in this section is going to be rational inequalities. So similar to rational equations, a rational inequality is going to be an inequality containing variables in the denominator. So I'm just going to read this part. Inequalities involving one or more rational expressions are rational inequalities, like 5 over x plus 4 greater than or equal to 1, and 2x minus 1 over 3x plus 4 less than 5. Those are rational inequalities. So they give you a list of steps. On page 156. So on the first step, we're going to rewrite the inequality if necessary, so that 0 is on one side and there is a single fraction on the other side. Second step, determine the values that will cause either the denominator or the numerator of the rational expression to equal 0. So these values determine the intervals on the number line to consider, and use a test value from each interval to determine which intervals form the solution set. So a value causing a denominator to equal 0 will never be included in the solution set. If the inequality is strict, that is, if it involves only greater than or less than, but not equal to, any value causing the denominator to equal 0 will be excluded. If the inequality is not strict, that is, if the inequality involves greater than or equal to, or less than or equal to, any such value will be included. We are going to solve. Two x minus 7 over x minus 5 less than or equal to 3. Okay, the first observation is that unlike equations, we cannot bring the x minus 5 to the other side. So I'm going to write this with red, just indicating that this step is not correct. So 2x minus 5. So this is not correct. We cannot do that because we don't know anything about x minus 5. X minus 5 may be positive or negative. If x minus 5 is positive, the inequality symbol will be the same, but if it is negative, the inequality symbol will reverse. So we cannot do that. We need to make one side equal to 0. So let's do that. 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. And we're going to write everything with the same numerator and denominator. You know, the numerator of 3 is 1, and the least common denominator is going to be x minus 5. So this is the LCD, or the least common denominator, and we have 2x minus 7 minus 3 times x minus 5 less than or equal to 0. Okay, so I'm going to use the space on the right. 2x minus 7 minus 3x plus 15 over x minus 5 is less than or equal to 0. And in simplest form, 2x minus 3x is minus x, and minus 7 plus 15 is 8. So 8 minus x over x minus 5 is less than or equal to 0. And the rational expression changes sign if it becomes 0 first, or if it is undefined. So the rational expression above, or the rational expression on the left, changes sign only if x is 0 or x is 5. And not only that, since the inequality is not strict, um, 8 is going to be a solution. And 5 is not a solution, but 5 is not a solution. So we have 3 intervals now. From there, we have 3 intervals. The values that make the numerator and the denominator 0 are going to be the test intervals. The test intervals are negative infinity 5, 5, 6, 5, 8, and they to infinity. And the rest of the process is going to be like before. We're going to pick a test value inside each interval and determine whether the rational expression that we obtain is true. Okay, the first interval. Okay, so we're going to make a table with the interval, with the test value, and whether the original inequality is true. Is 2x minus 7 over x minus 5 less than or equal to 3? Is it true? Okay, so we're writing down the intervals and picking a test value inside each interval. So negative infinity, comma 5, we're going to pick 0. That's easier to evaluate. 0 minus 7 over 0 minus 5 is negative 7 over negative 5, or 7 over 5. But 7 over 5 is 1.4, so this is true. From 5 to 8, we're going to pick, let's take 6. We have 2 times 6, minus 7 over 6 minus 7, over 6 minus 5. So 2 times 6 minus 7 is 12 minus 7. 12 minus 7 is 5. 5 over 1 is 5. This is greater than 3, so this is false. And between 8 and infinity, if we evaluate 9, we have 2 times 9 minus 7 over 9 minus 5. So 2 times 9 minus 7 is 18 minus 7, that's 11. 11 over 4, it's 2.75. And 2.75 is indeed less than or equal to 3, so this is true. And that's it. We also found that 8 is not a solution. Well, that 8 is a solution because that will make the numerator be equal to 0 and we have less than or equal to. But 5 is not a solution because it's going to be undefined, because the expression is undefined. So the solution set is going to be the union of two intervals, that's negative infinity, 5, with a parenthesis because we're excluding 5, but we are including 8. And I will do one more example to finish the section. So we will solve for x minus 1 over x minus 6 greater than 3. So once again, we cannot bring the x minus 6 to the other side because that may be positive or negative, and that might change the sign of the inequality. So we don't know whether the inequality changes sign or not. It really depends on the value of x, so we cannot just multiply that. We need to set this, make one of the sides equal to 0, and write a single rational expression on the other side. Okay, the least common denominator is x minus 6. So we have 4x minus 1 minus 3 times x minus 6 greater than 0. That will give us 4x minus 1 minus 3x plus 18 over x minus 6. So 4x minus 3x is x, and minus 1 plus 18 is 17. Okay, so we have two intervals. I mean, we have three intervals. So the expression changes sign at 17, at negative 17 or 6. So the right, well, I didn't have to delete everything, but the rational expression changes sign at -17 and at +6. And since the inequality is strict, because it involves greater than -17 and 6 are not part of the solution set. Are excluded in the solution set. Okay, so we had 3 test intervals. We're going to go ahead and make the table with our interval a test value and we will determine whether for x minus 1 over x minus 6 greater than 3, whether this is true. The test intervals are -infinity to -17. -17, 6, and 6 to infinity. So test values we can take on -infinity to -17. We don't have too many options, so we're going to do, or we have many options, but the simplest I can think of is -18. Okay, so this is going to be what? That's going to be 4 times -18. That's -72. -72 minus 1 is -73. Over -24. That one is going to be 73 over 24. So a calculator check will confirm that this is greater than 3. So this is true. In -17,6, we can go ahead and evaluate 0. So that's going to be 0 minus 1 over 0 minus 6. This 1/6. But that is less than 3, so this is false. And on 6 to infinity, we can evaluate 7. So 4 times 7 minus 1 over 7 minus 6. 4 times 7 minus 1 is 27. 7 minus 6 is 1. This is greater than 3, so this is true. And finally, we found that the expression is true for -infinity to -17 and 6 to infinity. So the solution set is going to be the union of these 2 intervals. So final answer, the solution set is -infinity, -17. And we're not including the end values because the inequality is strict. Union 6 to infinity. Thank you for listening.